5G applications at a glance. So enhanced mobile broadband, enhanced mobile, so it is going to achieve gigabits per second smart buildings. Okay? Smart buildings are having all the interconnectivity is there. Okay? All the interconnectivity is there. Voice, smart home city, okay? The smart home city, which is having all the interconnections, industry automation, 3D video games, work on play in the cloud. Nowadays, everything is cloud computing, and self-driving cars. Of course, this feature is also there in the 5G. This one feature, and the mission is critical industry. So all these are the plans of the 5G communication. So 5G communication connecting the communication. So you can see smart home, smart city, energy, healthcare. Well, generally, it's IoT and the devices and 5G is used in IoT devices in healthcare applications also. In medical applications, it is in biomedical applications is also suited. Okay. In education it is used smartphone, virtual reality. Nowadays, virtual reality, augmented reality is also gaining importance. So this 5G technology is the innovative concept of virtual reality also. And now it's just 5G IoT. How this 5G IoT is
you worst fellow.
Different internet functions to things. It is how it's going to different things are connected through the net here. Connected to the net. Everything is connected to the net, and everything you can control through the net. Okay, so this is Internet of Things. So speed, signal, big data, internet, network, technology, Internet of Things, traffic. All these are the different features. So this 5G technology, coming to the conclusion. So we discussed about the basic concepts and wireless communication and evolution of different wireless technology. Yesterday, the resource person Dr. Ryan Professor had discussed about the basic concepts of wireless communication and evolution of different wireless technology from 1G to 5G. And Sir also introduced about the 5G technology. And today we have done the comparisons from 1G to 5G. And what are different features of 5G technology, and what are the different prominent 5G technologies that are communications out there, and the technical challenges and business scopes. What are the different technical challenges are there, and facing that what are the different business scopes and applications of 5G. And 5G generally having, you can see that it is having vast and very good research scope available that is in the 5G wireless communication. So there is a scope for good research in this 5G wireless field. Because you can see that it's an you can see that the 5G is an ocean, you can take, because it's having vast scope. So it has covered important points in this 5G technology, covering the technical challenges, important technologies that are used, and what are the research scopes, what are the things and points for the research scope that are available. So thank you everyone for participating in this. Thank you everyone.
Vital?
I thank all the participants for participating actively in this seminar. Now, any queries are there, you can please post in the chat box. You can discuss about the queries.
Vital?
Yeah.
Yeah, some participant posted the queries in the chat box. So I will to read that queries.
Yes. I am seeing the queries. Actually, what is PAPR is there? What is PAPR is there? Peak average power ratio, which occurs due to the coming of carriers together. So it is the ratio of average power to the peak power to the average power. So high PAPR always increases the complexity of parity and DTI converters. It's a drawback. PAPR is another. You can remember that PAPR is a drawback, but high PAPR is a drawback. That is there in this file. And one more question is, can we get 5G network even in such mediums or such that they may be underwater, etc.? Yes, of course, the system is designed so that there is participants are requested to mute your mic, please. Participants are, there's some disturbance, please. Participants are requested to mute your mics. Mute your mics, please. So, in latency point of view, GFDM is more latency compared to OFDM. Why do you go for GFDM? So, one more question is asked here. Latency point of view. Latency means you can say that it's a delay, less delay. GFDM generally has less delay when compared to the OFDM because it allows multi-scheduling. It allows multi-scheduling. And also, circular convolution is there. The circular convolution of data that is going to take place in this particular this one. So we can expect less delay in GFDM compared to OFDM. Okay. What are the specifications of parameters for quality of service? One more. What are the specifications of quality of service? So parameters for quality of service include link reliability is very important. So suppose the transmitter receiver is there. The link should be reliable without any interference. So that is one of the good performance. Less interference, there is one more feature. That you have systems should be designed with less interference, minimum interference. Of course, zero interference is not possible because ideal systems, there is an ideal system. In practical systems, definitely noise and interference come into picture. So we need to minimize the interference, we cannot completely cancel, but we can minimize the particular interference and improve the quality of service to the customer. And how this 5G technology finds research applications in cryptography. So cryptographic applications, so 5G technology finds applications because cryptography is nothing but you are going to encrypt the data, some bits there, and such that the receiver side you are going to decrypt the bits such that no hacker can hack that particular information. So 5G technology employs robust cryptographic testing. Robust, that means more stable cryptographic testing. That's why it is used for this particular cryptographic testing. And also the system should be designed such a way that it is going to support. And what about the cost? The system about the cost, of course. Already discussed by discussing the technical challenges that you have to, whenever you design some complex hardware and complex software, the cost may become more. So you have to see that such a way that the cost is economical. The cost becomes economical. Of course, the solution is that signal more. You are employing sophisticated signal processing algorithm. You are employing sophisticated, highly developed signal processing algorithm, and this in this particular this one to minimize this particular risk. Okay? Scope. One more question is, what about the scope of artificial intelligence in 5G? So there is scope also. There is because see, everybody remember that artificial intelligence, deep learning, machine learning, all these are interrelated. They are not different. 5G technologies can be employed. There can be have the scope of artificial intelligence in 5G. Yes, it is there. Artificial intelligence, machine learning, all the data science, all these are intermixed. So you can have this. You can use this particular 5G technology in the this one. Okay? Right. And one more question is. Channel is dynamic in nature, which is unknown. How do you deal with the channel estimation in 5G? So channel is dynamic in nature, which is unknown. How do you deal with channel estimation? So channel estimation, remember that is always channel is a crucial medium where noise and interference comes into picture. Even though channel will not be completely known because channel has to be estimated. Whenever you are transmitting a signal itself, the channel must be known. The channel state that is called as channel state information. CSI must be known both to the transmitter and receiver. So the parameters of channel are impulse response, frequency response, etc. They need to be carefully estimated and then they need to be designed. Right. Still any questions are there? Please you can post the questions, please. The audience are requested. So how can you approximate a real-life channel in a simulated environment? How can you approximate a real-life channel in a simulated environment? Yeah, that is one more question, the request question. Actually, wireless communications, of course, they concentrate on more on simulation basis only. More the simulation results are there. That is there. And you can one solution that you can do is you can implement those applications in a processor like DSP processor. One of the solution is DSP processor like hardware, and you can implement some FPGA. You can write some VHDL code also, and you can implement in the hardware. those applications you can write in the VHDL code also, and then you can and also one more thing is that you can integrate the wireless applications and with the VLS applications also, such that you can see some real life applications are there. Okay. Yeah, one more question is there any increase in the antenna? Yeah, of course. The antenna size is massive. When you go for the massive MIMO, definitely the antennas, the massive MIMO is requiring large number of antennas for the transmitter and receiver. Okay, a large number of antennas for the transmitter and receiver employing. Okay, so definitely there will be an increase in this one. And of course, you should not think that the architecture is complex. You have to make such a design optimize. That's called optimization. Design optimization is very important. You have to optimize the design. The optimization means when you are having there is a trade-off between, suppose for example, you are achieving one advantage, then you have to forego one disadvantage. Suppose VR performance you are achieving more, then you have to sacrifice the transfer power, like that. So like that, the trade-off must be carefully maintained. The trade-off must be carefully maintained. Okay. One more question is reference books. This is certain reference books. There are a lot of books that are available. Mr. Ravi Kumar has posted a question. Ravi Kumar, there are a lot of books that are available in this particular 5G. You can go to any standard author. You can check a standard author like Andrea Goldsmith or Rappaport or any other authors. Reputed authors you can refer for the 5G. And of course, you can see the net also for more references, but see always the standard references written by the standard author. Okay. As one more question is, as 5G is low power consuming, but MIMO uses large number of antennas, how can the power be minimized? So the answer to this question is, even though the uses more number of antennas, that's why you have to develop the power low power design algorithms. You have to concentrate on power design also. Because it is employing more number of antennas, you have to concentrate on simultaneously, you have to concentrate on power level allocations also. You have to intelligently allocate the power and see that the power is minimized in the solution. Okay. Right, thank you everyone. Thank you everyone for participating.